Okay, so let's add this chain rule of differentiation as well, no? If you could remember, guys, if we have, let's say, for example, no, let's have an arbitrary function. Arbitrary function, we have this, let's say, x squared plus 1 cube, no? So let's say we want to find the derivative of x squared plus 1 cube, no? So this will be equal to 3, no? Due to the chain rule. We have 3 times x squared plus 1 squared. And then by the chain rule, finding the derivative of this, we have 2x plus 0, basically, diba? And then don't forget the dx. Since we do not have here an over dx, no? We have this by the chain rule. Now, if we want to integrate this, if let's say we want to integrate this 3x squared plus 1 squared 2x dx, this will therefore be equal to x squared plus 1 cube plus c, right? Again, due to the property of the inverse, no? The inverse operation of differentiation and integration. Now, if we have this problem in integration, it will be confusing, no? Let's say we do not know this yet, no? We do not know this yet. If we integrate this as it is, or if we simplify this even more, we have here 6 times x squared plus 1 squared x dx. We might get lost in our integrals, no? If this is what we can see in the problem, now we do not know that this will be just the solution. And basically the chain rule of differentiation has its opposite or its inverse counterpart in integration, which is called the U-substitution. So what is the U-substitution? Basically, that is just the chain rule, no? In this, guys. So if we have this differentiation, okay, so let's have another context in differentiating this. So instead of x squared plus 1, what if we make this u? So let's change this into u. So u is equal to x squared plus 1. So the differentiation here will become u cubed, no? Okay, so the derivative of u cubed will be 3u squared, okay, multiplied by the chain rule, we have du, okay, du. And then if we differentiate this u, if you could recall, no, the differential of u here, so du, that is equal to 2x, no? So the derivative of x squared is 2x, and then don't forget the dx, no, as well, and then plus 0. So we have here, we could change this u and then du into 3 times 2x, sorry, not 2x, but u is equal to x squared plus 1, so we have x squared plus 1 squared, and then du is equal to 2x dx. So we have this similar, no, similar to what we did last time. So basically, if we have an integral that looks like this, okay, so let's create another slide to avoid confusion. Let's say we have again this integral of 6x squared plus 1 squared, and then we have here x dx. We could utilize the U-substitution, wherein we could make a certain part of the function as u. So we could make this u, no? So we could let u as x squared plus 1, okay? And then also find the derivative of u. So derivative of u is equal to 2x dx, okay? And then replace the u and the dx, no, of our equation. So this will be equal to 6 times the integral of u squared and then x dx. So actually we have to also find this dx. So dx here, okay, simplifying this, we have dx is equal to du over 2x. Okay, guys, we simply just cross multiply this 2x here. So dx is equal to du over 2x. Ayan. So this will become multiplied by to du over 2x. So as you can see, we can cancel out this x here, and then this 2 here, we could factor out outside of our integral, so that this will become 6 over 2, the integral of u squared du, which is also equal to 3 integral of u squared du. Now, how do we integrate this function? We have the power rule again, no? So we multiply, or sorry, we add 1 to the exponent. We have u raised to 3, okay, over 3, okay, basically 2 plus 1, and then plus c. So we could cancel out this 3 here. The answer should be u cubed plus c. But again, we know that u is equal to this, diba? So therefore, simplifying this is equal to x squared plus 1. No, this is equal to u cubed plus c. And this is our original problem, no? Okay, so I hope this is clear. Let's try doing this, no, as practice through our examples. Ayan. So evaluate the given integrals. We have this integral of x times x squared plus 1 squared dx. Okay, so in here, we could replace this x squared plus 1 into u, so that our integral can reduce into its polynomial form, no? So we could let this as our u. So by u sub, we have to let u is equal to x squared plus 1, and then find the derivative of u. So du is equal to, so derivative of this is 2x. Don't forget the dx, guys. And then for the dx as well, okay, we have to also change this dx. So solving for dx here, we have dx is equal to du over 2x, ano, upon cross multiplication of your 2x. So therefore, we have the integral of x times, so x squared plus 1 will now become u, and then squared, and then dx will now become du over 2x. Okay, so we could cancel out this x here. We could factor out this 2 outside. So we have 1/2 the integral of u squared du. So integrating this u squared du, we have, okay, the general power rule. We have u cubed over 3. So multiply this and then plus c. So the answer should be 1 over 6 u cubed plus c. So multiplying this 2 and 3, we have 6. And then that is not the end. We have to also replace again this u. This will be equal to 1 over 6 x squared. No? So u is equal to x squared plus 1. We have x squared plus 1 cube plus c. So this will be your final answer. If you want to check if your answer is correct, find the derivative of this, and this will be your answer. This should be your answer. Okay, so let's have another one. Alright, so we have this given function. We want to find the integral. Again, if this is your function, it will get confusing. You know? So we have to use a U-substitution. We have to try. There is an element of trial and error in U-substitution. So using our U-substitution, let's change this up, no? So we will let this 2 plus x raised to the 4th power as our u. So let u is equal to 2 plus x raised to the 4th power. And then after doing this, we also have to find the derivative, since we also have to replace this dx. So we have to change everything up except this one, no? Okay, I will have an explanation later why do we have to not change this up. Okay, so the derivative of u, that is equal to, so this will be 0, and then this will be 4x cubed dx, no? So solving for dx, this is also equal to du over 4x cubed. Okay, replacing our u here and our dx here, this will be equal to the integral of x cubed over u squared, okay? And then dx, we have du over 4x cubed. Okay, so we can cancel out this x cubed, and then we could factor out this 4 here. So since it is in the denominator, this will still be in the denominator upon factoring. So we have du over u squared. as our integral. Now, guys, we do not have a formula in this form. So, if you have here a polynomial in the denominator, you can transform this as a reciprocal of u squared, wherein we could change the exponent into its negative. So we will negate this exponent. We have here 1/4 the integral of u raised to negative 2 du. Okay, because again the formula is u raised to n du is equal to u raised to n plus 1 over n plus 1 plus c. So it should be in this form, and at this case your n is negative. So n can be negative. It could be negative, it could be positive, it could be rational, it could be irrational, except it could not be negative 1. If the n is negative 1, again, u raised to negative 1 du, that is equal to ln of u plus c. Okay, again, n is not equal to negative 1, n is equal to negative 1 here. So we have two formula for polynomial functions. Okay, so let's simplify this. We have 1/4 times u raised to negative 2 plus 1 over negative 2 plus 1. So negative 2 plus 1, guys, that is equal to negative 1. So multiplied by u raised to negative 1 over negative 1 plus c. So simplifying this, we have a negative 1 over 4 u raised to negative 1 plus c. So transform this u into its original variable. We have this negative 1/4. We have 2 plus x raised to the 4th power raised to negative 1 plus c. So this will be your final answer. Or you could also have another an alternative solution. This could also be 1 over negative 4 times 2 plus x raised to the 4th power plus c. Ayan. Okay, so next, to evaluate the given integrals, we have this. Ayan. So again, we could utilize the U-substitution. So we cannot really distribute this x, guys. No, we cannot distribute this x. We cannot do anything else. We could change this into u, and possibly this one as well, and also this dx. So we have u is equal to 3x plus 2, okay, and then du is equal to, so the derivative is 3dx, okay, so therefore dx is equal to du over 3. All right, so let's try substituting the values first. Okay, so we have the integral of x times square root of u, and then du over 3. So we have du over 3 here. Okay, so the reason why we do not change this x for most of the time that we did last time is because we might cancel this out. But since we did not cancel anything after substituting this dx, we have to change this up as well. So changing this up as well using this U-substitution, we could create another equation that represents x in terms of u. So this u is equal to 3x plus 2. We want to solve for x here. So transpose this u. We have u minus 2 is equal to 3x. Therefore, x is equal to u over 3 minus 2 over 3. Right? So this will be equal to the integral of u over 3 minus 2 over 3. Right? Okay, and then we have here this square root of u, and then du over 3. Okay, so simplifying this, actually we could simplify this by factoring out this 1/3. So factoring out this 1/3, we have this u minus 2, and then 1/3, factoring out this 1/3, and also this one. So we have 1/3 times 1/3 the integral of u minus 2 times the square root of u du. Now, distributing the square root of u as well, and then simplifying this, we have 1 over 3 times 3 is 9. The integral of u square root of u minus 2 square root of u, okay, du. Okay, so u square root of u, guys, if you have u square root of u, that basically means we have u raised to 1 multiplied by u raised to 1 half. And if we have a multiplication of two polynomials, this will be equal to u raised to 1 plus 1 half, which is a rule of the exponents. So this will be equal to u raised to 3 halves. Okay, and then this square root of u will be also equal to a fraction, no? So we have 1 over 9 integral of u raised to 3 halves minus 2 u raised to 1 half, and then multiplied by du. Okay, guys, since we have two terms, we have to distribute this integral for each one. So we have also this, don't forget also this 1 over 9 and this du. So we have the integral of 1 over 9 u raised to 3 halves du minus 2 over 9, the integral of u raised to 1 half du. Okay, this is equal to, okay, by the general power rule, so plus 1. So 1 over 9 integral, times u raised to 3 halves plus 1 over 3 halves plus 1 minus 2 over 9, and then multiplied by u raised to 1 half plus 1 over 1 half plus 1 plus arbitrary constant c. Okay, simplifying this, we have here 1 over 9, and then u raised to 5 halves. So 3 halves plus 1 will become 5 halves. And then over 5 halves. And then minus 2 over 9. And then u raised to 3 halves over 3 halves plus c. Simplifying this, we have to reciprocate this, no? So the reciprocal of this is 2 over 5. So we have 2 over 5 times 9. So 5 times 9 is 45. So I'll just put here 45. And then u raised to 5 halves. Minus, we have here 2 over 3 halves. Sorry, 2 over 9. And then we have 2 thirds pala, no? 2 thirds. So this will become 4. 3 times 9 is 18. 27. And then we have u raised to 3 halves plus c. So is this your final answer? So not yet. You have to change this up again to its original variable, which is x. So you have u is equal to 3x plus 2. So changing this up, we have 8 over 45. So u here is 3x plus 2. So we have 3x plus 2 raised to 5 halves minus, we have 4 over 27. And then u, we have 3x plus 2 raised to 3 halves, and then plus arbitrary constant c. So this will be your final answer for this problem. Okay. So next one. Alright, so we have a definite integral in combination with a complicated function, no? So again, we have to utilize the U-substitution if it is not obvious that there is a direct integration of the function. So we want to make this, so the goal here is to write this into a form that we have in the table. And so far, we only have two formulas for u raised to n du. So we want to change this up into this form. So we have to use u substitution to simplify this 5x plus 4 into just u. So we have to let u is equal to 5x plus 4. And then derivative of u, that is, so again, if you have this u, find the derivative as well. So we have 5 dx. And then after that, so we have to change this. We have to also change this. So dx is equal to du over 5. Ayan. Okay, so let's set aside first this definite integral. We want to first treat this as an indefinite integral. And then later on, we will evaluate this at its limits. Okay, so simplifying this. What is it? Okay. So we have the integral from 0 to 1 of, we have 1 over the square root of u. So this will become u. Okay, and then the dx will now become du over 5. So du over 5. So this will be equal to the integral from 0 to 1 and then factor out this 5 here. So we have 1 over 5, and then du. Square root of u pala, no? So square root of u is also the same as 1 over u raised to 1/2, and then du. And then this square root of 1/2 in the denominator can also be changed. So this is also the same as u raised to negative 1/2. So if it is in the denominator, if you put this in the numerator, you just have to change this sign. Okay, so evaluating this integral using this rule, which is equal to u raised to n plus 1 over n plus 1 plus c. So in here, we have n is equal to negative 1/2. So this will be equal to 1/5 the integral from 0 to 1. We just evaluate this. We have u raised to negative 1/2 plus 1 over negative 1/2 plus 1 evaluated from 0 to 1. Okay, so we have, what is this? So negative 1 plus 1 is u raised to 1/2 over 1/2. Okay, evaluated from 0 to 1. So this will be, the reciprocal is 2. So we have 2 over 5 u raised to 1/2 from 0 to 1. So now we have to get things back now first from u to 5x plus 4. So changing this up, we have 2 over 5 and then 5x plus 4 raised to 1/2 and then from 0 to 1. Okay, so now we can substitute the the values of the lower and upper limits to x. Okay, so we have to first substitute the higher limit, no? So this will be equal to 2 over 5. Okay, just set aside this constant since this will be just a simple evaluation. So 5 times 1 plus 4 raised to 1/2, and then minus, we have 5 times 0 plus 4 raised to 1/2. So we have 2 over 5. This is equal to, so 5 plus 4, that is 9. So 9 raised to 1/2, or in other words, when we're saying raised to 1/2, we're saying, no, so 9 raised to 1/2 is also the same as the square root of 9. So the square root of 9 is 3. Okay, we'll just evaluate this later. And then we have, so this will cancel into 0. So the square root of 4, so 4 raised to 1/2, or the square root of 4, that is equal to 2. So we have here 2 over 5 multiplied by 3 minus 2. So this is equal to 1. So therefore the answer should be, okay, so the answer should be 2 over 5. Ayan. If we evaluate a definite integral, it will become constant value. Ayan. So this is the final answer. Alright, so let's try more examples. So we have a lot of examples here. So evaluate this integral again. So if you could recall the integral of cosine u du, that is equal to sine u plus c. But the problem here, guys, we could not directly integrate this because this is not in the u form. No? So we have to change this up into u using the U-substitution. So the integral of cosine u, no, du, we know this. So we have to change this up. So u is equal to 3x. Therefore, du is equal to 3dx. And dx is equal to du over 3. So substituting the values, we have cosine of u, and then dx is equal to du over 3. And then factoring out this 3, we have 1/3 the integral of cosine u du. Yan. So evaluating this, we know that the integral of this is sine u plus c. Therefore, the answer is 1/3 sine u plus c. But that is not the final answer. So change this back again to its original variable. We have 1/3 sine 3x plus c. So this is your final answer. If you try differentiating this, this will be your answer. Ano? Okay, let's move on. Okay, so the next one is we have cotangent 3x or raised to 3 halves. Sorry. Let's sort this out. Oh no. Where is my... Sorry, where is my presentation? Sorry, guys. So just check my answer so far. Okay. Ayan, no? So we have this given problem, and again, our angle here should be just u or just x enabled to be to evaluate this given function. So we have to change this 3x over 2 again into u. Okay, but if you can recall now, what is the integral of cotangent u? Okay, actually we do not have an integral here shown for cotangent u. But let me just show you that the integral of cotangent u, that is equal to, cotangent u du, that is equal to ln of the absolute value of sine u plus c. So I will add this later to our formula during class. So the integral of u here, that is equal to, the derivative of u here, 3 over 2x, that will be equal to 3 halves. So therefore, dx is equal to 3 du over 2, right? For 3 halves, du for your dx. So change this dx, change this u. So this will be equal to the integral of cotangent u multiplied by dx, that is 3 halves du. So this will be equal to, so factor out this 3 halves. We have 3 halves integral of cotangent u. So this will be equal to ln of the absolute value of sine u plus c. And then don't forget to change the u. We have 3 halves natural log of sine 3 halves x and then plus c. Okay, so let's move on to another example. So take note of this in your integration table. Okay, so we have this integral. We have to integrate this two terms of a trigonometric function. So the first thing to do, if we have more than one term, we can distribute the integral sign and the variable of integration dx. So this will be equal to the integral of, also we can factor out this 5, after this. So we have 5 tangent 4x dx minus the integral of 3 cosecant squared 4x dx. And again, we can factor out this 3 and 5. Okay, so now how do we integrate this? Alright, how do we integrate this tangent 4x and this cosecant squared 4x? Okay, actually we do not have, I have not shown you yet the integral of tangent u, but I have shown you the integral of cosecant squared u. So the integral of tangent u du, that is equal to natural log of secant, okay, secant u plus c, or actually there are two solutions to this. You can also have negative natural log of cosine u plus c. Okay, more on to that later if you ask me during class, why is this equivalent. And then the integral of cosecant squared u du, that is equal to, we call this cotangent, so negative cotangent u, okay, plus c. So again, we have to change this angle. Instead of 4x, we have to change this into u. So u here for both of them, so since they are the same, we have to make this u into 4x, and then du, derivative of u, which is 4 dx. So therefore dx is equal to du over 4. So changing this up again, so this will be equal to 5, the integral of tangent u, and then dx is du over 4, okay, minus 3, the integral of cosecant squared u, and then we have du over 4 as well. And then simplifying this, factoring out first the constants, so that is also important. Okay, we have the integral of tangent u du minus 3 over 4 the integral of cosecant squared u du. Okay, so again, the integral of this is natural log of secant u, and then this one is negative cotangent u. So we have 5 over 4 ln absolute value secant u, and then minus 3 over 4 negative, no? So negative cotangent u plus c. So even though we have two terms, again, we only have to add one arbitrary constant. Okay, so this will cancel out, and then we have to also change this u. So we have 5 over 4 ln of secant 4x, and then plus 3 over 4 cotangent 4x plus c. So this will be your final answer. Okay, so moving on, we have another here. We have a lot of examples, you know. Okay, so evaluate the given integrals. Alright, so this looks complicated enough. So how do we do this? Should we use U-substitution? Actually, we do not need to use U-substitution here. Alright. If we use substitution, no, if we let this as U, no, we cannot really change this up. No, we cannot cancel anything. So, if you could recall, we could actually factor this out in your algebra class. So we know that x cubed plus 1, that is equal to x plus 1, okay, multiplied by x squared minus x, right, plus 1. Is that correct? Okay, so therefore, we have to factor this out so that we could cancel this x plus 1. Okay, so what's the next step here? Okay, so we have to find the integral of this, which is x plus 1, x squared plus, minus x plus 1 over x plus 1 dx. So cancelling this x plus 1, this will become the integral of x squared minus x plus 1 dx. And then integrating this separately, so this is equal to the integral of x squared dx minus integral of x dx plus the integral of dx. So this will be equal to, due to the power rule, we have x cubed over 3 minus x squared over 2 plus x and then plus c. So this will be your integral. Yeah. So do not forget the factorization. Now we have a lot of algebraic concepts that we need to remember in able to rewrite our function, no, so that we could integrate them. Okay, now what is this? No, so we have this given function, no, hw, and the definite integral of hw from 4 to 9, wherein hw is a piecewise function. So a piecewise function meaning it has a different function for a given integral, for a given interval. No? So for the interval here, we have 4. For the interval here, we have 3w plus 1. So how do we visualize this? Let's visualize first the function. So hw, no, is has a function here that when w is less than 6, so meaning if this w is less than 6, and this hw is our y-axis. Okay, so when when w is less than 6, so let's say this is 6. If it is less than 6, then w is equal to, h of w is equal to, let's say this is 4. So this will be your hw. Okay, and then when your what do you call this? When your w is greater than or equal to 6, 3w plus 1 will be your function. So 3w plus 1, how do we graph this 3w plus 1? So that's the what do you call this? The y-intercept of w is 1, so this will be your 1. And then using this slope, so we have rise over run. So we have rise, no? rise of 3. So we have 1, 2, 3. Sorry, this is not up to scale, no? So let's say this is 1, and then we have 1, 2, and 3. And then the run will be 1, so this will be your line. Let's say this is your line, therefore your W, okay, the real W here for this HW function will be this portion. So this will continue on and on and on. And we are only interested in the definite integral from 4 to, let's say, this 9. So what we're trying to find here is this area from 4 to 6 and this area from 6 to 9. So we have a piecewise function wherein we want to find the area of this and we find the area of this. So basically, we want to find the integral. Oh, so this is the same as saying that this integral here is equal to a piecewise integral from 4 to 6. Okay, so from 4 to 6, the area of this HW. So since the function here is just 4, so this will be just 4W dW plus this area here from 6 to 9. So we have 6 to 9, and then the function here will be 3W plus 1. So this height here is 3W plus 1. Again, this is 4. So we have 3W plus 1 dW. Okay, so simplifying this, we have 4, the integral of from 4 to 6 of dW, and then we have plus the integral from 6 to 9. Sorry, we could just directly integrate this. Okay, let's directly integrate this. Okay, so the integral of dW is just W. So we have 4W integrated from 0, evaluated from 4 to 6. And then plus, so what is the integral of this? So we have W squared over 2, right? So we have 3W squared over 2. And then plus, so the integral of 1 or dW, after substituting this dW, is W. And this should be integrated, evaluated from 6 to 9. Okay, so let's write this again in another slide. Okay, so upon evaluating the definite integrals, we have to substitute this 6 and this 4 here upon knowing that this is the integral of the function. So we have here 4 times, we have 6 minus 4. Actually, you can do this now. You can factor out as well the 4. And then for here, for this other term, we have to substitute this 9 and this 6 now for each. So we have here 3 times 9 squared over 2 plus 9. Okay. And then minus, we have 3 times 6 squared over 2 plus 6. And then that's it. So simplifying this, we have 4 times 2. So this is 8, right? Plus, we have here 18. That is 9 times 9 is 81. So 81 over 2 times 3. Okay, this gets complicated now. So we have 3 times 81 over 2 plus 9. And then minus, we have 3 times 36 over 2 plus 6. Okay, now how do we simplify this? So we have 8 plus, so 3 times 81 over 2. This seems complicated, guys, now. So 3 times 81, we have here 3. So 3 times 8 is 24. We have 243. So 243 over 3 plus 9 minus, not 3 but over 2. Okay, and then 3 times 36. So 36 and 3, we have 18. 3 times 3 is 9, and then 10, so we have 108. So minus 108 over 2, so distribute this negative sign for both, and then minus 6. So simplifying this, so 8 plus 9 minus 6, we have here 17 minus 6, so 11. Okay? And then for this 2, we have plus 243 minus 108 over 2. So 243 minus 108. Okay? We have carry over this 3, so 13. We have 5, and then we have 3, and then 1. So 135 is equal to 11 plus 135 over 2. But we have to combine this 2 into 1. So we have 22 over 2 plus 135 over 2. This will become 22 plus 135 over 2. That is equal to, so 135 plus 22, that is 7 plus 5 plus 1. So 157. 157 over 7 will be your final answer for this definite integral, which basically also mean that this is your area. So 157 over 2 yung kanyang area in square units.